Hello, Miss Walsh here. So today we're going to look at how to graph exponential functions and their transformations. So a few basics about the exponential functions. This is the general shape of it. So it has quite a growth. And if we do a little, I've taken two examples here. And if we do a table of values here, for example, so if we do 2 to the power of 0, that'll give us 1. 2 to the power of 1, 2. 2 squared is 4, and 2 cubed is 8. And if we take a look at the negatives, just recall your exponent rules a little bit. Hopefully you remember that 2 to the negative 1 is a half, and 2 to the negative 2 is a quarter. Okay, so it grows very, very quickly on the positive x values here, and on the negatives it's actually receding. It's tending towards 0, which is why there's the dashed line there. As we've already met, there is an asymptote there. If we took a look at the y values of the 3 to the x instead, so just a different base, then what you would find, 3 squared is 9, and 27, you would find that this is causing it to grow faster. So this graph would be steeper than this graph. And again, if we just check our negatives, then 3 to the negative 1 is a third, and 3 to the negative 2 is 1/9, okay? To find the y-intercept, we just substitute 0 into the function, okay? So this is its general form if it has not got any transformations, and if there's a stretch or a shift up and down, then it will look like this. And the b does have to be positive. And any number that you substitute in here, positive or negative, any real number gives you a positive result, which is why the range of this parent function is that it's greater than 0. Not equal to, because right at 0 there's an asymptote. Okay, so now let's apply this and graph this with some transformations. Okay, the first, let's answer the questions first. So first of all, it's asking us for the y-intercept. And so we already know how to do that, right? We set x to be equal to 0, and that will lead us to y is equal to -2. 0 plus 1. 0 plus 1 is 1. So we know that the resulting y-intercept will be 2. The equation of the asymptote. Okay, if you notice, if you look at the transformations will be such that this will be a vertical reflection. So we're going to flip all the y's. And then the +1 is inside the function. So what we're going to do is we're going to go one left. So we haven't gone up or down, which means that the asymptote stays where it is. So this function will still tend to y equals 0 is the asymptote. So okay, let's just start there, and let's just graph that asymptotic line. There it is. Okay, and what we're going to do now is we're just going to graph the parent function first, okay? So the parent function here is 2 to the power of x. And we already know the table of values from the work we've done above. So this is 1. Be careful of the scale here, actually. Here we're using 2 steps for 1 unit. Here we're using 1 step for 2 units, so it's a little bit tricky. Okay, so this is at 1. And then 2 to the power of 1 is 2. 2 to the power of 2 will be 4. 2 to the power of 3 is 8. And 2 to the power of 4 is 16. And then we've got our half, we've got our negative values, the small values there. Okay. So this is the parent function. Okay, so now I'm going to reflect it, okay? So from 1, I'm going to go into -1, and then at 2, -2, -4, at 3, -8, at 4, -16. Draw as smooth as you can. Yours can only be nicer than mine. Okay, and the equation so far here is 2 to the power of x, yeah? And so what we need to do now is we need to shift everything to the left. So let's do that. There we are. There we are. That should be higher. And then 2, -4. So this was at 3, -8. So now it's at 2, -8. And 4 minus 16 is now 3 minus 16. And it's still tending towards there. Just to quickly mention, remember that we ended up, when we substituted in, we ended up with the y-intercept being -2. So let's just see how that happened. That actually ended up being this point right here. So we had a point that at 1, we were at 2. This point then got reflected, and it then became -1. 1, -2, and it then shifted 1 to the left, and then ending up being 0, -2. So there is that y-intercept indeed. Okay, so for yours right here, draw the parent function of 3 to the x first. Be careful, this is inside the brackets, and this will be a vertical translation, so you will have to move the asymptotes as well. Ciao, ciao.